Hi everybody, welcome to another video in Trigonometry section 7.3, the law of cosine. So we spent the first two sections earlier to study about the law of sines, and we say that the law of sine is used when we have a pair of opposite angle and sine. Then it is natural to say that when do we use the law of cosine? Well, that is where we cannot use the law of sine. But first, the law of cosine is this. In a sense, we see a version of it in the Pythagorean theorem, right? In the right triangle, we can say c squared equal to a squared plus b squared minus 2ab cosine c. Cosine c being 90 degrees, cosine of 90 degrees. Cosine of 90 degrees is equal to 0. So that's why we don't have that. And that is the Pythagorean theorem, right? So the Pythagorean theorem is the special case of the law of cosine. So the law of cosine is that if we start with the sine c, we will end up with the angle c. Everything in the middle are the two other variables, a and b. So a squared plus b squared and then minus 2ab, the other two variables. But c, start with the sine c, end up with the angle c. So that's what the law of cosine is. And we use the law of cosine when we cannot use the law of sine. So use the law of cosine when we cannot use the law of sine, meaning that when we don't know when we don't have a pair of opposite angle and sine. Right. So just jump right into an example. We have this triangle knowing all the sides. Right. By the way, I think this is a typo. Yeah. Because if we have 4.7 and 5.2, they add up to be 9.9, which is less than the third side. We will not have a triangle in that case. So please, I would change this in the note, but just make this 14.1, then that will work. So I'll change that in the note before I upload this online. So we know the sine opposite to A is sine A 14.7. B is opposite from B 5.2, and C is opposite from that 10.1. Yeah. Right, we don't even need to write, but let's just write out the summary, what we need to solve for. Right, in this case we know all about the size. 14.7, B 5.2, and C 10.1. We don't know the angle A, don't know angle B, and don't know angle C, because we don't have a pair of opposite angle and sine. We have to use law of cosine. So my question is, which one do we use? There are three of them, right? Well, now, but first, before we jump into that, In this situation, we have all three sides. So this is the sine scenario. When we use the sine scenario, we're going to use the law of cosine. From my experience, it will be best if we work with the biggest side. Usually, like Pythagorean theorem, right? We work with like the hypotenuse should stand by itself. So work with the biggest, the longest side, because in that case that will give us the biggest angle. Right. So I will write out a square. So we use the law of cosine. And I use a square equal to, if I start from a, I will have the other two variables in the middle, but the last one is going to be cosine of the same letter, a and a. Right. Now, in this case, we know all the sides, so we're just going to solve for cosine of a. So I move b squared, c squared to the other side. Right, equal to negative 2bc times cosine of a. Yeah, subtract b squared, c squared, and then we divide by negative 2bc. So cosine of a squared minus b squared minus c squared over negative 2bc. Right. Recommend we use the calculator here, even though it takes some time, but it will be useful later. Right. Now, a 14.7 store into a, alpha a. B 5.2 store into b. 10.1 store into c. Now just enter this. On the top, a square minus b square minus c square divided by negative 2bc. Notice use this negative sign, don't use subtract. That gives us negative 0.8 to a6 something. If we want to get back to the cosine, to get back to the angle, we would use cosine inverse. Of course, in cosine inverse, we also have that and the opposite, right? Sine, we have the supplement, cosine have the opposite. But since this is a triangle, the measure of an angle cannot be negative. So that's all we have. Nice thing about law of cosine is cosine inverse. That's it. No other option. So I will just do cosine inverse here. But make sure it is in the degree mode. Before we enter the trig function, just make sure that we know if we are in the right mode or not, because that makes the whole thing incorrect. Right, I just copied the whole long number, and I have 145 degrees. Sorry, 145.96. degree. Right, so that's it, right? Now, of course, we can do the same thing to find angle B. But if we want to find angle B, we start with the sine B. So, B square equal to A square plus C square minus 2AC cosine B, right? If I start with B, I end up with B. Right, if we solve for it, subtract a square and c square to the other side, we have negative 2ac cosine b, and then divide by negative 2ac. So we have cosine of b is equal to b squared minus a squared minus c squared over negative 2ac. The good thing here is we already entered ABC, so we just need to enter this b squared minus a squared minus c squared divided by negative 2ac. We have that, and then the cosine inverse. Cosine inverse of that. We already have in degree mode. So that's 11.42. This is B, right? Yeah. And then of course we can use the same thing, log cosine, do the same thing, and solve for cosine of C and then take the inverse. But since we know all of them, all two of them, subtract from 180, we should have the answer. So 180 minus that, and then minus that, 22.62. Simple enough, right? And final check. Biggest angle, longest sine, smallest angle, shortest sine. That check. Right. So, like I said, I highly recommend that when we have the sine, when we use the log cosine to find an angle from sine, go with the biggest one first. Because later on, we can still use log sine if we choose to. But log sine, they might be the supplement, which could be a problem. So, whatever we find, we know for sure that is the biggest angle. So that's what we go with, and that's what we have. Next, solve for the triangle if A is 5, B is 6, and C is 47. When we used to it, we don't even need to draw the triangle. Let's see if we can do it without drawing the triangle. If we're not drawing the triangle, at least draw the summary, so it will be very helpful. Right, what we have is sine A is equal to 5, sine B is equal to 6, and angle C is 47 degrees. We do not know A, we do not know B, and we do not know C. Yeah, of course we can do the math from here, but the reason that I draw the triangle, just so we can see what scenarios do we have here. Right, we have C, that angle C, 47 degrees, sine A, opposite from A, and sine B. So in this case, we have a sine and another sine and the angle in between. So by drawing the triangle, we know this is the sine angle sine scenario. Remember, it's very important that most of this is fine, but the case when we have sine, and angle, that's when we potentially have two solutions. So it's nice to know that we don't have to deal with the sine, and angle. So this one, most likely will have one solution. Should be one solution, right? If it is sine, and angle, that's going to be, it might be two, it might be one, or maybe no solution. That is section 7.2. Right, now, since we do not have the pair of opposite sine and angle, right? We don't know c. So in that case, we have to use the law of cosine because we cannot use the law of sine. Of course, there are three of the law of cosine, and which one do we use? Well, that should be simple. We only know angle C, so we have to use the formula that has the angle C. So, law of cosine, using the one that has the angle C, c squared equal to a squared plus b squared minus 2ab cosine C. Right. Since now I'm going to find C, I'm not going to store AB in that. I'm just going to say C squared. Just put all the numbers in A, B, minus 2AB, we find 6. And then cosine of the angle between them 47 degrees. So just do that. 5 squared plus 6 squared minus 2 times 5 times 6, so just 60. Cosine of 47 degrees. Make sure it is in degree mode. Yep. 20 point something. But we don't want c square, we want c, right? So we have to take the square root of that. Give us 4.481. Yeah. Now we have a pair of opposites sine angle. Of course, now we know 3 sine, we certainly can use the law of cosine to find the angle too. But it will be better just use the law of sine here, where we have the opposite sine angle. Alright. So let's just write sine of A, which we don't know, over sine A we know is 5. Sine of B, which we don't know, over sine C we know is 6. Sine of 47 degrees over the sine of 4.48. But from here we just take the ratio that we want, like here. We can solve for B and then take inverse. I mean sine of B, then take inverse. So 4.48 sine B equal to 6 sine of 47 degrees. So I'll just take inverse. I mean solve for sine B first. Six sine of 47 degree divided by, take the whole number, don't round off. Only round off at the last step, right? I'm just going to write the number, but I'm not going to use that. If I want to find the angle, that will be sine inverse. (78.3 degrees). That is angle B. That makes sense because this angle is bigger than that, the side should be longer. Right. So we have that. Next, we just need to find angle A. Of course, we can use the law of sine with the first ratio and the last ratio, but since we know 2 of the angles, just subtract from 180. That would be best. Yeah. Of course, this is the notion of we should use the number that is given and not the number that is calculated. calculated, because when we calculate there might be some rounding off. Well, but in terms of math, we assume that the numbers we use all the decimal places that we can use. So in that case we just subtract. And I have 54.69, so 54.7. So biggest angle, longest side, smallest angle, shortest side. That's good. Right, so that's all we do. Right, next, show the triangle ABC. If we have those sides, by the way, this case we don't have to draw anything because we have 3 sides, so this is side scenario for sure. So I'm just draw a summary of the triangle. Obviously we know 3 sides. And we don't know any of the angle. And this is side. So for side, we're going to use the log cosine, because obviously we cannot use a log sine without knowing a pair of opposite sine angle. And also I recommend that when we use a log cosine for the sine, go with the one with the biggest angle or the longest sine. So I will start with the longest sine. Therefore, what we solve for is going to be the biggest angle. Later on, if we have to use the law of sine, we don't have to worry about the supplement, because what we find here is going to be the biggest angle. Alright, so we once again subtract a square b square. Sorry, if we start with b, we end up with b, but anything in the middle have to be something else. B square minus a square minus c square equal to negative 2ac cosine of b. So cosine of b equal to b square minus a square minus c square over negative 2ac. Right. Yeah, we can store the numbers in, or we can just do the math. Since the number is simple enough, 10 square, 4 square, 5 square, negative 2 AC. So yeah, if the number is too simple, it's not worth storing the number, because type 4 is faster than type 11. Previously we have a bunch of decimal numbers, a little more complicated, so I will type that. That will be shorter than type the number itself, but of course you can always just type the whole numbers in. We have negative 1.475, so cosine of b and then of course cosine inverse. We don't have to worry about anything, because sine we have the supplement, cosine is opposite. We're not going to use opposite here because the angle must be positive. Well, in this case there's even no solution here, because cosine has to be between negative 1 and 1, so here we have no solution. And now we look back. If the side is 10, one side is 4, one side is 5, they cannot join to make a triangle, right? So that's why this is no solution. One side is way too long, longer than the other two put together. So So that's why there's no solution, because there's no triangle. I thought I'd do that. That's why in the first problem I just look at that and said that's not going to work, so that's why I have to change the problem. Right, now look at an application problem. A ship due north, so go north, at two different points A and B that are 2,000 meters apart. The navigator of the ship signed a lighthouse at point C, where the bearing from point A to C is 42.3 degrees. So that's why we have the bearing here. North 42.3 degrees is. Suppose the distance from A to C from the boat, and that is 5,686 meters. Determine the distance BC. So now let's just write the summary here. What do we have and what don't we have? Right. We have angle A. This is opposite to angle C, so 2,000 meters is sine C. This is opposite to angle B, so this is sine B. And we have the angle between two known sine, so this is sine angle and sine. So yeah, when we have two sines and an angle, make sure that it is not sine angle situation, not SSA situation, because we might have an ambiguous case there. Besides, the ambiguous case have to have angle and the sine opposite to each other. So without drawing the triangle, if I have A and sine A together with sine B, if I know this information, I know for sure this is going to be sine angle. Simply because in this case we use the law of sine. So the sine angle, the ambiguous case sine angle, we use the law of sine. We won't be able to use the law of sine here because we don't have the opposite sine angle. So that means this is not sine angle. We know that for sure. We have at most one solution. Right, just go ahead and do that. So the first question, find the distance from B to C. Distance from B to C, which is the length BC opposite to A. So the first question here, from B to C, that is BC, which is equal to A. And that is our first question. Okay. So we just do that. So of course don't have the opposite sign and angle, so use law of cosine. With the angle A, so we have to start from sine A. So B square 2,000 square plus, C square, sorry. That's fine. 5686. That number is way too long. A square equal to B square 5686 C square 2,000 minus 2 B C times cosine the angle A, which is 42.3 degrees. Right? So just enter all of that. 5686. Okay. 5686 square plus 2,000 square minus 2 times 5686 times 2000 cosine of 42.3. Is that in degree mode? It is. So will be that number 195.08426.38. So taking the square root of that, we have 4416, which is reasonable, so comparable to this number. If we have like 1000, those two put together is not equal to this, right? So make sure when we have the answer, check that if it makes sense. So the distance BC is equal to 4,416 meter, and that is equal to BC. Right, next, how much further due north the ship must travel to reach the closest point to the lighthouse? Meaning we have to find the distance BD. Well, it's actually easy than we think. If we draw the triangle, the shortest distance have to be the perpendicular. Now, if it is the right triangle, we don't have to use log sine, log cosine. We just use the basic trigonometry, because with respect to that angle, this is going to be adjacent to it, and this is hypotenuse. So whatever ratio that has adjacent and hypotenuse, we can use that. So it's either cosine or secant, but let's use cosine. So cosine of 42.3 degrees equal to adjacent over hypotenuse. Adjacent is AD over hypotenuse, which is AC. We know for sure 5,686. Yeah, so when the triangle is the right triangle, we don't have to use a lot of sine, cosine. Right, so we just use basic trigonometry. So AD will be equal to 5,686 times cosine of 42.3. 5,686 times cosine of 42.3. So will be that. Yeah, just make sure I entered. Okay, good. 4,200, and let's say 6 meter. Right, so we have the distance AD is that much. Subtract AB, we have BD. So finally, if we want to find the distance BD, it is equal to AD minus AB. So AD is that much. AB is 2,000. So we end up with 2,206 meter. Right. So that's what we have for this problem. And that's all I want to cover in this section about law of cosine. So we use the law of cosine when we cannot use the law of sine. And that means we don't have the opposite sine angle. That's where we use law of cosine. Usually it will be sine, 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 and sine angle sine. When we have sine, 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 we use the law of cosine with the biggest angle, with the longest sine first. That's what I would recommend. Of course, you can start with any one of them. And then when we use the sine angle sine situation, there's only one option because we only know one angle, so we know exactly which law of cosine we use. But that's all we have in this section. As always, thank you for watching and see you in another video in trigonometry.